Finding the equation of a line. So when finding the equation of a line, there are a couple of different forms of a straight line that we can use, and we would use different ones in different situations depending on the information that we have. So the key thing about finding the equation of a line, and we talked about this when we were sketching linear graphs, the minimum amount of information that we need is 2 points. Any 2 points will allow us to sketch that line, any 2 points will allow us to find the equation of that line. Obviously it would be convenient if we knew the gradient, but if we weren't told the gradient, 2 points, we can still calculate the gradient. It's also convenient if one of the points that we're given is the y-intercept, because that makes using gradient-intercept form really easy, because we can straight away fill in one of the unknown values in the equation. So gradient-intercept form is a good option where you're told about the gradient and the y-intercept, you should be able to write the equation straight down, or where you're told about 2 points, one of which is the y-intercept. In all other situations though, where I don't know the y-intercept, I personally would use point gradient form, which is this: y minus y1 is equal to m brackets x minus x1. This is a rearrangement of the gradient formula really, and the advantage here is that we need the gradient, which is m, and any point with coordinates x1, y1, and we can use this form. So I tend to use this form when I can. If I have the y-intercept, I'll use gradient-intercept form. It is possible to use gradient-intercept form for all problems. So I'll show you a couple of different ways to do some of the examples. So let's have a look at the first example. We wish to find the equation of the line which has a gradient of 3 and passes through the point 0, 7. So the first thing I'm recognizing here is that 0, 7 is a y-intercept. It's a point on the y-axis. Gradient of 3. So straight away I've got the gradient and the y-intercept. No messing about. I can write down my equation. Gradient of 3, y-intercept of 7, y is equal to 3x plus 7. Let's have a look at this next example. We wish to find the equation of the line that passes through the point 1, 3. So that's not a y-intercept, it's not on the y-axis, and is parallel to the line y equals negative 2x plus 7. So parallel means that it's going to have the same gradient. So y equals negative 2x plus 7 has a gradient of negative 2, which means that our line is also going to have a gradient of negative 2. So we've been given the gradient and a point, not the y-intercept. So I'm going to use gradient point form. So y minus y1 is equal to m brackets x minus x1. So x1, y1 is my point, 1, 3, and m is my gradient. So y minus the y coordinate of my point is equal to the gradient multiplied by x minus the x coordinate of my point. And so we have y minus 3 is equal to negative 2x plus 2, just expanding the brackets on the right hand side, adding 3 to both sides, y is equal to negative 2x plus 5. And so there we have the equation of our line. You could use, as I said, gradient-intercept form for all of these problems, and I'll show you how to do that here. So obviously we immediately know the gradient. So we know that y is equal to negative 2x plus c, but we don't know c because it's the y-intercept, but we have another point. And remembering the problems that we solved in the video titled Equation of a Line, we know that if we know a point, we can substitute that into the equation, because a point is telling me that when x equals 1 for this equation, y must be equal to 3. So we can use that in order to solve for c. So I'm going to substitute the point 1, 3 into my equation. So y is equal to 3 when x is equal to 1. And so now we have an equation that we can solve for c. So 3 equals negative 2 plus c. Adding 2 to both sides, c is equal to 5. And so now I know both m and c. And so therefore y is equal to negative 2x plus c, which is 5. So both give you the same result. I just find the first method nicer in that it allows you to substitute all of your known information in at the first step and then just simplify. whereas gradient-intercept form requires you to substitute the gradient, then to substitute the point, solve for c, then to put c back into the original equation. It's just a bit more disjointed, but it's a perfectly valid method. Let's have a look at another example. Find the equation of the line passing through -2, 5 and 0, 3. So I've got 2 points, but I note here that I do have the y-intercept, so I will probably use gradient-intercept form in this case. So I know that the y-intercept is here, so that means that c will equal 3. So I just need to work out the gradient. I've got 2 points, so I can do that. Rise over run, change in the y values, over change in the x values, which gives me 2 over -2, so we have a gradient of 1. So we have a gradient of 1, a y-intercept of 3, so my equation is y equals 1x, or just x plus 3. Example 4, we have 2 points, neither of which is the y-intercept. So I'm going to use gradient point form, but I'm going to need to calculate the gradient first, obviously. So rise over run, change in y over change in x. So 7 minus minus 2 is 7 plus 2, which is 9, over 1 minus minus 4, which is -1 minus minus 4, which is -1 plus 4, so 3. So my gradient is 3. So I'm going to use y minus y1 equals mx minus x1. So it's y minus the y coordinate of my point. Now I can use either point. I'm going to go with this point in this particular case, but wouldn't matter which one I used, I'd get the same result. So y minus 7 is equal to my gradient, which is 3, multiplied by x minus the x coordinate of that same point, which is -1. So we have y minus 7 is equal to 3x, so it's x plus 1, so we're going to get 3x plus 3 when we expand that out. Adding 7 to both sides. So my equation is y equals 3x plus 10. Again, I could have used y equals mx plus c. Substitute my gradient. Then substitute the point, y equals 7 when x equals -1. Solve for c. Substitute m and c back into gradient point form. So again, an alternative method, perfectly valid. The last example here, we want to find the equation of the line that is perpendicular to the line with equation y equals 2/3 x minus 3 and passes through the point 1, 6. So our line needs to be perpendicular to this line, and this line has a gradient of 2/3, which means that for our problem, the perpendicular gradient will be the negative reciprocal of 2/3, so -3 on 2. So we're going to need to use m equals -3 on 2 for this problem, and we have a point 1, 6. So gradient and a point, the point isn't the y-intercept. So again, I'm going to use y minus y1 equals m x minus x1. So y minus the y coordinate of the point, which is 6, is equal to the gradient, which is -3 on 2, x minus the x coordinate of the point, which is 1. Expanding out, so -3 on 2x plus 3 on 2, adding 6 to both sides. And so 6 is the same as 12 on 2, so we've got 3 on 2 plus 12 on 2, so plus 15 on 2. Given all those fractions, you might choose to write this in general form, but it certainly wouldn't be required. So we could multiply everything by 2. 2y equals -3x plus 15. Add 3x, so 3x plus 2y is 15. You could also take the 15, so 3x plus 2y minus 15 equals 0. All are perfectly valid equations for this line.